Hello, algebra students. We're looking at section 6.2 today, simplifying radicals of higher roots. Yesterday, we only looked at square roots. All of the radicals had the index 2, so they were square roots. But today we're going to be using higher roots. Remember, the index can be 3, 4, 5, and so on. So we're going to look at some of those today. We have this reminder: when using the cake method, the index tells you how many of each number you need to make a group. So we'll be doing the cake method. We'll get the prime factorization, and we get that prime factorization in the same way as we did yesterday, but then the number that we need to make a group, okay, depends on the index. So it won't just be 2 every time like yesterday. Okay, so let's look at the first one. We want the 5th root of 256. So we'll do our cake, and we'll do it right side up again. So we have 256, and we might as well use 2, and that gives us 128. And then what prime factor do we want to use for that? Well, we'll use 2 again. And so 128 divided by 2 is 64. And so 2 goes into that as well, so we'll use 2 again. And 64 divided by 2 is 32. And 2 goes into that, so we'll use 2 again. And then 32 divided by 2 is 16. 2 goes into that. 16 divided by 2 is 8. Okay, and 2 goes into that as well. And that gives us 4 when we divide that by 2. And then 4, we might as well divide it by 2. Okay, and then that gives us 2. And just to complete the cake, we can divide that by 2 as well. And now we have 1 on top. So all these 2's down the side, they're all 2's. That's our prime factorization. Okay, so now we want to look for groups, but it's groups of 5, because the index is 5. Okay, so we have these 2's. We'll group 5 of them. Okay, and just like before, anyway, and that's all the groups we can make. Okay, there's no more groups of 5. So there's just one group, okay, one group of 2's, so a 2 comes outside the radical. And then inside the radical, we have what's left over, which is these 3 2's down here. So inside the radical, we have 2 times 2 times 2. And so we'll rewrite that. And 2 times 2 times 2 is 8. So we have 2 times the 5th root of 8 is the simplified form. Okay, let's look at the next one. Cube root of 135. Okay, so we will use the cake method on 135. Remembering our index is 3 this time, but we get the prime factorization in the same way. Well, 5 goes into 135. We know that. And so 135 divided by 5 is 27. And here we will use 3. Okay, so 27 divided by 3 is 9. And The prime factor we have to use for 9 is 3. And 9 divided by 3 gives us 3. And then we can only use 3 there. And we got our candle on top. 3 divided by 3 is 1. Okay, so how do we do the grouping here? Well, we look at the index. You always have to look at the index. It's 3, so we want groups of 3. And we have it. That's a group of 3. That's the only group of 3. So one thing from that group comes outside the index. So it gives us a 3 outside, or outside the radical, I mean. We write the radical. The index, of course, is the same. And then inside the radical goes the leftover. Well, all we had was 5. So that's it. 3 times the third root of 5, or we could say the cube root. 3 times the cube root of 5. Okay. Or the third root. You can say it that way as well. All right. The rest of these have variables. So we deal with those the same way we did yesterday, except the size of each group will be different if the index is something other than 2. Okay, so let's look. Look at the first one. We have the cube root of 500x to the 7th. So we will factor that 500, make a cake, use 2, and that gives us 250. We can divide that by 2. That gives us 125. Now we can't divide that by 2. It's not an even number, but of course we can use 5. And 125 divided by 5 is 25. Okay, we used 5 again. And 25 divided by 5 is 5. And now we're to a prime number, so all we do is divide it by itself. And 5 divided by 5 is 1. And now we have it all, it's all caked out. And we look for groups of 3. And we have a group of 3, but just one group of 3. It's those 5s right there. So we bring out, since we only have one group, we bring out only one 5. We have to write down the x's too and look at those. Okay, let me back up. Not quite ready to write that, because we are also going to have we have variable here, which is x. So we have the multipliers, the factors that is, that are in this x to the 7th are just the x's, right? And there's 7 of them. We can put them in 2 rows like this. 7 x's. So we're looking for groups of 3. So we do have, we can draw it like this. Well, let's do it this way. We have a group of 3 here. Right times there, showing it goes across. We have another group of 3. Okay, so now we do have all the groups, and we're ready to say, okay, we have one group of the 5s. So we bring out a 5. We have 2 groups of the x's. Okay, so there are 2 x's, and we could write them like this, but that we would really, since it's x times x, we just write it as x squared. Okay, so that's what comes out of the radical. Everything else is inside. and that is these 2's down here. So that's 2 times 2. And what about x's that are still inside? Well, we just had that one leftover x. So we will rewrite that because we can simplify it a little bit more, right? 5x squared times the cube root, and 2 times 2 inside there, that's 4. So we have 4x. And that's it. Now, we might get a little bit more sophisticated with counting the groups of x's. We know it's x to the 7th power. So if we just take 7, we know there's going to be 7 x's multiplied. So we can just divide that by 3 because our groups that we're looking for are groups of 3. So dividing 7 by 3 tells us how many there are. How many groups of 3 are there? Well, 7 divided by 3 tells us that. And there's 2. Okay, now we have to see what the remainder is as well, right? So 2 times 3 is 6. Subtracting, you get 1, and that's your remainder. So that tells us that we have, oh, sorry, erase this. That tells us this 3 tells us, well, there's 3 groups of I'm sorry, no, we divide by 3 to see how many groups there are. The 2 tells us there are 2 groups. Okay, 7 divided by 3 is 2, so there's 2 groups. The remainder tells us what's left over. So we have our 2 groups of x right there. We bring them both out. 2 x's out, that is, because there's 2 groups of x's. And so that's x squared outside the radical, and inside the radical we had a remainder of 1, so we have 1x inside the radical. So you can do this either way. We can use just writing down the x's like we did down here, or we can do it with this division. Actually, for this one, I could label everything here. So this is the index. Okay. This is the number of groups. And then the remainder is, we'll just call it remainder. And remember that that's how many of those x's is left inside the radical. Okay, let's look at the next one. So we have to do the cake on this 243. Okay, so 243 divided by, we'll use 3 for the prime. And that gives us 81. Oh, we can use 3 again. And that gives us 27. Divide that by 3. Well, 27 divided by 3 is 9. 3 goes into that and gives us 3. And then we're done. So we say we have to, the only factor we can divide by is 3. And we have the cake on, the one on top, the candle on top. Okay, and I'm going to go ahead and write down the x's here. We have x times x times x, and that is the other variables as well. Well, we have y times y times y, and we have 4 of these z's. Okay, so let's look at this and figure out what to bring out of the radical. Our index is 3, so we're looking for groups of 3. And as far as the prime factors, we do have a single group of 3, but that's it. And then for the x's, we have this group of 3. And you got to look at all the variables, of course. For the y's, we have this group of 3. And for the z's, we have a group of 3. So what do we pull out of the radical? Well, we pull out a 3 because we have one group of 3's. We pull out an x because we have one group of x's. We pull out a y because we have one group of y's. And we pull out a z because we have one group of z's. And then what's inside? Well, we still have these two 3's left over, so that's inside. Let's just go ahead and multiply that. That's 9, right? We know we have 3 times 3 inside. We know that's 9. So we'll just write it down. And then we also have this other leftover z. Okay? So that's it. All right, look at C. We need to do our cake on the number. So take 128, divide it by 2. And that gives us 64. So divide that by 2. And that's 32. Divide that by 2, and that's 16. Divide that by 2, and that's 8. Divide that by 2, it's 4. Divide that by 2, and you get 2. And divide that by 2, and it's 1, and we're done. For the x, we'll show both ways of doing this again with the x's and the y's. So you have just a single x, but for y, you have 8 of them. So y times y times y times y, that's 4 times, we'll just go ahead and, there's our 8 of them. Okay, so now we look for groups. We're looking for groups of 3 among these factors. We have a group of 3 2's. We got another group of 3 2's. And we've got a group of 3 y's. And we've got another group of 3 y's. And looks like everything else is left over. So, what comes out of the radical? 2 of these 2's, because we have 2 groups of those. Okay, and then we'll bring out 2, but we know that 2 times 2 is 4. Let's go ahead and multiply those together. Okay, there's 2 groups of 2's. We bring out 2 2's, and that's 2 times 2, which is 4. And then what goes inside the radical? Everything that's left over, which for numbers, that's just 2. That's all that's left over right there. For the variables, let's see, we've got an x and we've got 2 y's, right? And we've got 1 x. So we have x, that takes care of that one. But for y's, there's actually a couple of them. So y times y, so that's y squared. And so that's inside the radical. Oh, I didn't write down both my y squareds outside the radical. So I've left something off. Sorry about that. I got to back up. So outside the radical, yes, we do have 4, but we have more than that. So outside the radical, we have that 4 that came from 2 times 2, because we have a 2 from that group, because we have that group of 3, and also the other group of 3 gives us another 2. So that does give us 4, but we also have outside the radical a y from that group and a y from that group. So that's y times y, right? That's y squared. So that's what I left out. Okay, and then inside the radical, I had that correct. So 4y squared times the cube root of 2xy squared. Again, we could do a shortcut if we wanted to. We could look at those y's and we say, well, there's 8 of them, and we want to know how many groups of 3 there are. So 8 divided by 3 will tell us that. Okay, so that's 2, and then 2 times 3 is 6, and so we have a remainder of 2. That tells us how many y's remain inside. So sure enough, let's see, let me write up here. Oh, sorry. How did I label that before? Well, yeah, number of groups. So this 2 is the number of groups. And down here we have the remainder. I'll call that again remainder. It tells us how many of those y's remain inside the radical. Okay, and that's 2, right? And that's the way we did it. We'll get the same thing whether we use it, whether we do it this way with the division, or whether we do it as we did down here by writing down the y's and the x. Okay, one more. So we will do a cake on this 64. Divide it by 2. That gives us 32. Divide that by 2. That gives us 16. Divide that by 2. Gives us 8. Divide that by 2. Gives us 4. Divide that by 2. That gives us 2. And we can divide that by 2 to get 1. Now we've got it. And we have to look at the index. This is the 4th root. So we've got the prime factorization, but we need to look at the index to see how many are in a group. We go ahead and write down the m's as well. So we have 5 of those. And the n's, we have 3 of those. And then for p, we have 8 p's. 2, 3, 4, 5, 6, 7, 8. Let's see if I can move this over just a little. Nope, looks like that's it. Okay, 8 of them. Squeeze them in there, or actually write one more at the beginning. Okay. So we need groups of 4, right? So for the 2's, yeah, there's a group of 4, and for the prime numbers, that is, and that's the only group of 4 we have there. Then we look at the variables. We have a group of 4 here for m's, and for the p's, there are 8, so we have 2 groups of 4. Okay, So what comes out of the radical? Well, we have a group of 2's, so a 2 comes out. We have a single group of m's, so an m comes out. We have 2 groups of p's, so it's p times p, or p squared. Okay. And so now we see what's left in the radical. It's the 4th root. We write our 4 there. And what's still in there? Well, we have 2 times 2 in there, which is 4. And we also have these other leftovers down here, the others that are not in a group. And with the variables, we have this m. And then we have these n's down here. They're not in a group either, right? So n cubed. And that's all we got. Okay, so that one was pretty long. You had a lot of variables we had to look at. But if we're careful, we'll get them. We'll be okay. Okay, so that's all the examples we have to look at for simplifying radicals of higher roots. I just remember it's not just 2 in a group anymore. The number in a group comes from the index. We look at that index and see how many need to be in each group. So that is all for now. See you later.